Alright guys, welcome to another video, and in this video I want to explain each concept I did in the last video step by step. Now in the last video, as you know, I tried to explain all of the components of this machine, right? I explained the y-axis, I explained the y-axis, the x-axis and the z-axis. If you don't have a link to that video, I will link that video in this particular video so you can watch that first before you watch this one, because that one explains overall what you need to know before you build a 3D printer. Today we'll just focus on one of those axes because this printer is so complex that any one of the axes is a lot of work on its own, so you can't really understand the entirety of what you need to know if you watch just that one video. So this is a sequel to that, and the other video after this also is a sequel to this, so you just stay tuned to this channel, because like I promised in the very first one, and if you've not seen that, it's here. I said I'm going to explain this machine from the beginning all to the end, and it's going to be for free. So I'm not putting it on the partner program or anything like that. I'm just going to keep it for free for everyone anywhere in the world to watch. All right, so let's start. So remember in the last video I told you that this machine uses 3 different axes. It uses X, Y, and Z. Today we're going to be focused on the Y axis, right? And it's important for you to understand the way the Y axis behaves so that you can understand its role in a 3D printing scenario. So to help with this, I'm going to first lift this Z-axis up now. One way you lift the Z-axis is just by twisting this knob, and then they'll go up. So I'm going to pause this video now and then take the X-axis, Z-axis all the way to here. Alright, so I've lifted the bed up considerably. You can see that I have enough room on this space, and all I did was twist the knobs, right? So now, the y-axis is the motion axis on this particular front and back space. So most y-axis controls the heated bed. This bed is just where you build the things, right? Almost every printing machine has a platform upon where you build. So the y-axis is mostly where you build, you know, all the things you want to build. So the machine is going to be moving on this particular plane, and that particular side is called the y-axis. Most 3D printers have their y-axis as the axis that controls the bed, right? Because the bed in this particular kind of build, the bed is stationary. In some builds, the bed goes up, right? But in this particular kind of build, the bed stays stationary, but it just moves along this particular axis. So you have to keep that in mind. In this particular style of 3D printing build, the bed is on the y-axis. Now, the y-axis itself is driven by this particular motor. This motor is obviously different from this motor, right? All 3 of them are the same kind of motor. All of them are stepper motors. In another video, I'll cover stepper motors and why that is what we use for 3D printing. But all of them are stepper motors, but it's just a different stepper motor. And why? Because when I bought my stepper motor for this particular axis, right? These types of stepper motors, when I bought them, I bought 6, I sold 1, and then the other one got burnt while I was making research. So I remember that I bought this particular motor in the past, so I then picked it up and used it. So it's obviously different from every of them, and all of that, you know, does have an effect on printing quality, as you will see in later videos. But just know that the y-axis is the axis that often controls the bed, right? Keep that in mind. So what I'm going to do right now is that I'm going to take all of these components off so that you can see what is working underneath, and I'll explain why they work the way they do so that you can get them. So first things first, I'm going to unscrew this heated bed. It has these tiny screws at the bottom. So I'm just going to take the bed off now. So let me pack these guys out of the way, and then I'll just take the bed off. Right, so the bed, you know, has 3 specific wires, but today is not the day I explain the heated bed, but I just keep that in mind. These 2 are for power, and then this is for the thermistor, but we're not getting there today, so we're taking it out. So essentially, the purpose of the y-axis is this bed. Like, this bed is the reason we have a y-axis. That is, in this particular style of 3D printer, we need somewhere to control the bed, right? The whole purpose of this particular y-axis is for this bed. So let me take this out, right? So you can set this aside like this, right? And then we'll go to this one. To keep the y-axis in place, right, we needed to find a bracket. Because I'm going all DIY, right, I had to use a foam board. In this place, you can use acrylic. In this place, you can use wood. You can actually cut a block, a slab block, right, and use for just a support. The heated bed is usually mounted with this particular springs, and the essence is that it needs some form of springiness when the head is working on it. If it was a rigid structure, by the time this head is chewing on that plastic, it will stay stuck, and then it's going to affect the print quality. So this guy needs something it can press down while it's working. So that's why these springs are there. In some cases, these springs are not made of plastic. They are made of metal. In this case, I think it's made of, I don't know what this material is. It looks like metal, but it's not like every spring. So even if you are trying to build your own and you don't have these exact same springs, don't bother. What you need here is a spring, right? Any kind of spring works, as long as it doesn't bend too easily, and then it's going to warp the print. So it doesn't really matter. So now, like I said, this platform was designed to house that plate. I don't know if you can see that guy on the far side, right? So that's the purpose of the wire. So this is the guy that we mounted to the wood that you were saying, were seeing initially. So now we're going to take out this place. To fasten this place up, I had to screw it down with your regular screw. I'm going to unscrew it now while you're seeing this video, and then you see what's underneath. All right, so you see, it's just a foam board, some piece of foam board I cut from my existing foam board. What I just had to do was I had to make sure it was thick enough. So this is about a 6 mm foam board, or I'm not sure this is up to 10 millimeters, but it's just a 6 mm foam board, something rigid enough. And then one other reason why I had to use a foam board was its lightness. Don't forget, this motor wants to drive the y-axis forward and backwards, right? If this thing is too heavy, it's like a slim guy that weighs 50 kg carrying a woman that is 100 kilograms. It's going to have a hard time moving that person forward. So don't forget, this motor wants to drive this axis. The heavier this axis gets, the more clunky it gets to move the y-axis. So we need things that are light. So when you're using wood, or maybe you're using any material, you have to consider the weight of what this guy is driving. This plate is going to be driven back and forth thousands of times during the print, sometimes 25,000 times during the print. You don't want something too heavy that will bog down, the torque of your motor. So you need something light. So even when I was choosing wood, I had to use pallet woods. All those woods that have holes in them that are not so heavy. So, but this is all for the base of the board, right? Now, next to that, I have these two woods. These two woods were playing two particular purposes in this particular setup. Initially, I just had a small plate like this, and I used zip ties to fasten it, right, to it. But you see, I had a bit of problem, and that was a wobble problem. Because I used zip ties to fasten it, the zip ties could not hold these bearings sufficiently enough. I don't know if you can see that bearing in the video. So because it could not hold this bearing efficiently, I had the wobbles. So now I had to make wood, because if I fasten the bearings inside the wood, it stays permanently there, and both of them stay permanently there. And as long as they are parallel, and as long as they are in series with each other, the wood keeps them in place so that the motion here can happen smoothly. Do you understand? So there are two reasons why we use wood here: to make sure the bearings stay permanent and stable enough for motion to happen effectively. So essentially, the purpose of the y-axis is we want to take readings for this motor. But we can't take readings for this motor if we cannot move efficiently along that axis, right? So the wood is serving, the first particular function the wood is serving is to keep these bearings in place so that I can move freely. Do you understand? I'm going to show you what kind of bearing I use in that place in a moment, but let's just continue with other explanations. All right. The second use case for this particular y-axis setup was also because my z-axis already was too high. if you look at under here now and under here, right, one of the things you'll notice is that because I had to use a bracket to hold this guy in place, the bracket head already extended to this high, right? So now the motor had to be suspended. In some other 3D builds, you'll see that the motor is on the floor. And the reason their motor is on the floor is because the bracket is holding it on this side. But in my current setup, I couldn't get a good bracket in my country. So this is the only bracket I was able to get in my aluminum store. So I had to use it as a workaround to ensure that the Z-axis stays permanent. So because of that lift that the brackets gave me, the motor had to stay up. And don't forget, the base of the motor is the lowest point of your Z-axis, because the motor cannot go lower than this place. So which means I needed something to lift my bed up enough to be higher than where this board is. So that's why I needed to add an extra wood on top of this guy. Otherwise, your bed will not be able to, your X-axis will not be able to kiss the bed, and then it needs to kiss the bed if it's going to run. I don't know if you understand what I'm saying. So that's pretty much why this setup exists. Under normal circumstances, I didn't need to add this extra one. I'm going to take this one out as well now. All right, so now I have it out, so you can see that this was the initial height of the bed. This was just an extra structure to lift the bed up. So now we take this out. Now this one. So now I'm going to deconstruct this particular y-axis now and show you why we set up the y-axis the way we did, what these rods are for, and why it works the way it does. Now, one thing I need you to pay attention to is that in the center of these two rods, let me position the camera again, right? In the center of these two rods is a belt, right? Now, these belts are timing belts, right? They are belts that have tooth to them. The tooth is also attached to a pulley that has the same tooth. Great. So now, this belt and this motor are the things that help us to take readings of positional data for the y-axis. So the software is basically connected to that particular board, and that particular board only takes reading from the motor. So the motor, therefore, is the reason why we are setting up the y-axis. So now, this particular wood now serves the third purpose, which is to fasten the belt to it. So we fasten the belt to this particular bracket. So every bracket you are going to have to use for any of your axes will have to figure out a way to fasten the belt to it. Now, I'll show you how we worked around this in a moment, but now I'm going to deconstruct the entire y-axis and then explain to you step by step what those things are doing, and then we'll conclude this video because I don't want it to get, too long and then it gets boring. All right, so now I'm going to take the belts out like this. So I'll take the belt out like that. I'll take the belts out. Right, so this belt. And then I'll also take this belt out, right? So now let me show you the belt. So it's just your regular belt. So I don't know if you can see it. It's just your regular belt. Why is the belt this thin? Because the size of this belt has to match the teeth of the pulley. And you notice that this guy has a longer tooth, and that's why we had to fasten this particular knob to it. But I use a super glue to fasten it so that you can keep the general distance of this to minimize the amount of wobble. If you didn't put this thing there, right, the belt will be going from here up, and all of that will eventually show up in your 3D print. So if you see some blemishes in your print, it's like you can see this particular line that is running across. That's a y-axis problem. So, and that's basically coming from the teeth of this. So the teeth of this belt must match the height of your pulley. You can use any one, but you have to make sure that this belt matches the teeth of your pulley. So keep that in mind. All right. So now that we have taken the belt out, you can see now that essentially this guy moves back and forth, right? There's nothing special he's doing than to move back and forth. But you see, this moving back and forth is what we want to read with the motor. So the motor is almost like a sensor that reads where this guy is. So if, say for instance now, your G code, we'll get to G code later, your G code is saying move Y by say 10 millimeters, This motor is what we're reading. It's not the thing. But we need a setup that helps us to read the motor effectively. All right. So now, one thing we're going to do is that I am going to then unscrew these guys and then take these out and then explain. So now, like I said, the Y wants to move like this, right? That's what the Y wants to do. First, we need to ensure that the Y is moving this way. So there are basically three components that make the Y move effectively. One is the bearing. Let me show you what that bearing inside there really looks like. All right, so this is the bearing that's in there. So I have four. I have one in the front, one in the front, then in the back also I have one. So that's four. Why should it be four? Why can't it be one? Yes, it can be one. It can be one on this side. But you see, it should not be one on this side alone, because if it's one on this side alone, then how do you get balance, right? Besides, if one rod is passing through here, and then this place is empty, doesn't make any sense, right? So we have four of these bearings. Most likely you're not going to get this in your country if you're not living in Europe or China or Asia. If you're living in remote parts of Africa or Nigeria, it's not remote, but we somehow don't have it, unfortunately, as great as Nigeria is, but we don't have it. So if you're living in a country where you can't find this, then you can use any other kind of bearing. There are some short bearings that stop around here. I have a picture, a video of it. You can use that as well. Let me see if I can find it. So if you don't have this particular one, you can use this, right? But because this is kind of short, you might have to need this in series so that you can have plenty of that so that it can guide the steps. So that's pretty much it. So if you don't have this, you use this. But you see, this also has something you use it with, right? And that thing you use it with is this rod. Let me show you a sample of that rod. All right, so these are called linear rods. This is an 8mm linear rod, and this bearing is an 8mm bearing. What both of them do is that this guy goes into this place. Why do we need that? Don't forget, the main goal is that we want to drive this motor. This motor is what we want to drive. We want to take readings from this motor. Your 3D printer is essentially all these motors. But you see, the motor is also doing work. And the work it's doing is that it's pulling this carriage. Do you understand? So now, to make this carriage move effectively, we need something the carriage can stay on so that while this guy is moving it, it doesn't fall off. Right, so one method we deployed in the y-axis is to use linear rods. But trust me, that is not the only method you can use. There are many options when it comes to building 3D printer. And in this video, I also want you to realize there are plenty ways to do it. So instead of using this rod, for instance, I could have used a linear rail. The function of linear rail is the same function that the linear rod does. We need a straight rod, and then we need a slider. This slider now is exactly the same thing as what this one is doing. The only difference is that this is called a rail, like your train rail, like a train track, and this guy is sliding across it. But they share the same similarities in that there's a Boris on the inside. I don't know if you can see that thing rolling on the inside. See, those things rolling inside now is what is making smooth motion happen. So essentially, therefore, your rods or rails are serving one singular purpose, a smooth motion. And the smoother your motion is, the easier it is for you to take readings from the motor, which is the actual purpose of this entire setup. Do you understand what I'm saying? Of course, in some cases, we could also use a linear screw. And in some other cases, you don't even need two linear rods. You could have just used one linear rod. So when you are trying to build your 3D printer, or maybe you are observing the current build on your 3D printer, you would see the choices your manufacturer has made for you. So if they choose one linear rail along the y-axis, it works for them. Like the Ender 3s, for instance, use one linear rail on the y-axis. Right, but in this case I'm using two linear rods. Why did I use two linear rods? I didn't know. Like, I just was ready to do anything, and this was what I came up with. Right, if I'm trying to upgrade this machine now, I can choose to put another aluminum block on top of this, right, and put a linear rail on top of that, and the linear rail will drive my y-axis. Right, so you can see there are plenty of options when it comes to building your machine, but you just go with what you have based on what you see, right? I don't know if that is helpful. So one last thing we're going to do now is to explain why we need these studs and why we need these two things, right? So you'll observe two things very quickly, that we have 4 studs holding the linear rod. Well, these studs, right, their function in this particular setup is just to hold the linear rod. Otherwise, what would have held it, right? We want the linear rods to stay permanent so that this guy can move freely. So the linear rods must stay permanent, otherwise this guy will not move freely. Now imagine if this guy was bent one way or the other, this guy is not going to have a smooth motion. Now, when you're building your own 3D printer, make sure by the time you come to this place, it stays, and by the time you go to that place, it stays. If you're doing this and it's bouncing back, that already shows you the motion is not smooth, it's not working right. It should be able to stay where you put it. Otherwise, something is wrong with your y-axis setup. It has to be free. If it is not free, this motor is not going to drive it right, and then you're not going to take proper readings from this motor. So your mechatronic 3D printer will not work right. So you have to keep that in mind. All right, so that's pretty much it. So I'm going to get a screw now and lose out these guys, and then that would be the end of the video. All right, to unscrew this, I used a what's this called now? An Allen key, right? So you just lose this out, right? Then lose this place, and then lose this place. Right? You could do the same thing for the other side. It doesn't matter at all. What you just really want to do is that you want to take that guy out. So I think I'm just going to have to use this place as well. Take this out, then take this out. Then also take this out. So I'm going to take this out. Okay. Alright, so I'll take this out. Alright, so you see I took the linear rod out like that. So I think that's affecting the camera. And then I also take this linear rod out. It's a bit tricky to do, but you take it out. So now you can see my y-axis, right? So like I said, I used one bearing on this side. Where are those bearings? Remember that bearing I was showing you, the longer one? This guy. This bearing, right? So I used 4 of them. One on this side, one on this side, one on this side, one on this side. When you're doing this kind of setup, one thing you want to achieve is that the bearings are on the same line, such that you can look through from one end to the other. Do you understand? Let's say this guy was on this side and then the second one was on this side. It's not going to work. Both of them have to be exactly at the same spot, right? So that's the tricky one. I had to drill both holes carefully to be able to achieve it. In the past, I was achieving a wobble, but now I don't have any more wobbles. All right? Now, one other thing, these are the screws that were holding the belt, because you just need something to fasten the belt to it. Nothing special, just fasten the belt to it, and then the belt stays stuck. So that's kind of like this. So this is like the carriage. It doesn't have to look like this. You can choose to, maybe in my other videos now, I'm going to upgrade this particular setup by actually printing the kind of y-axis that I want. It's just that when I didn't have the machine to print it, I had to use this to make it work. I bought this for maybe 500 naira in my country, and then like put it apart. I used a saw to put it apart. So that's kind of like it. So you see, the same smooth rod, nothing special, right? Same smooth rod. And then I use this guy. Let me take this one out so that you can see it. So I use this guy as a fastener. When you're working with aluminum, you're going to need to work with a lot of brackets. That's just the only challenge you are going to have with aluminum. So this is one of the brackets that I use to hold it. So 4 of this goes in there. And now, aluminum brackets always comes with these tiny little things called T-nuts, right? So there's all kinds of T-nuts. What T-nuts do is that they are slim enough to enter into the hole. And when they enter into the hole, they can twist. And so by the time you are tying them, they've twisted. And so because they've twisted, they can fasten this hole and keep things in place. They're great. So when you're buying your parts, you need to buy T-nuts. If you don't know what kind of T-nuts you need, then you have to hit me in my WhatsApp channel to explain to you. By the way, when people come to my WhatsApp channel, they get to pay money, so it's not like it's free. It's only my YouTube videos that are free, and I try to make sure it's as detailed as possible so that you don't have to come. But when you have to come, you're going to pay a consultation fee, even if I have to ship it in for you. So that's pretty much it. So that's all for the y-axis. The other thing you need to know is the motor. It's just the average motor, but I'm not going to cover the motors in this particular video. I'm going to cover it in another video. And then I have another pulley on that side. One of these days I'm going to cover pulleys because they themselves are a separate topic. If my motor was not this fat one, I would have used this particular pulley on top of the motor. So, and these pulleys are two kinds. You can't believe I didn't know when I was starting out. I thought this pulley was the same as this pulley, and they are not the same. This is the pulley on the motor. That is called an idler pulley, right? So that one has a bearing. This one doesn't have a bearing. And you can tell it doesn't have a bearing just by looking at it, right? But the idler pulleys have something like a bearing like this on the inside where the inner parts move separately from the outer core. But this particular pulley doesn't work. But I'll cover that in a later video about pulleys. So that's pretty much it. That pulley is on that side, parallel to this particular one, so that the belt can move on a straight line. And that's pretty much everything you need to understand in the y-axis. So let's go over what we said earlier, that the essence of the y-axis is to drive this particular plate. That's all. There's nothing else the y-axis is doing other than to drive the plate. And what is the plate for? The plate is the bed. And the bed is where you have this guy chew on to be able to do its printing. So right guys, I hope this has helped you. If it has, I want you to hit the subscribe button, hit the like button, turn on the notification bell, and I'll see you in the next video. Bye bye, take care.